Okay, so a programming paradigm for spatiotemporal composability. Modern software from plugin systems to self-evolving agent harnesses increasingly requires. Yeah, I've already read that. I've already read that. Let's get to the meat. Okay, they split the thing into two dimensions. They decouple the problem of composability to two types: the temporal composability and spatial composability. And yeah, they take VS Code as a study case, as a case study. They illustrate its limitations in the two aspects: temporal limitation. VS Code in this case runs all extensions in a shared process called the extension host. Although extensions can be installed dynamically, this host provides no mechanism to unload an individual extension's code at runtime. Once an extension activate function has been executed, disabling or uninstalling it requires. Let me also. Oh hey viewer. يا هلا. That's the paper. بالنسبة لحد يشوف very someone wants to check it. Okay, epic. Oh hey, Discord. Guess you on Discord? No. Okay, so wait a minute. Okay, so yeah, they take here قبل VS Code.com case study. They study it in they illustrate two limitations. Temporal limitation is that VS Code runs all extensions in a shared process called the extension host. Although extensions can be installed dynamically, this host provides no mechanism to unload an individual extension's code at runtime. Yo, Hamad Zain, your micro man, your microphone. Up. نينت راني ميتتك نينت الصوت اللي يحرق قلت unmute يا راسك. Once an extension's activate function has executed, disabling or uninstalling it requires restarting the entire host, affecting all loaded extensions. Purely declarative extensions such as themes, key bindings, and snippets carry no code and can be removed freely. Yeah, okay. Among the top 100 extensions by install count, however, 87 contain executable code and will therefore require such a restart upon removal. صيني ما يعرف الإنجليزية وما يعرف كتب. I get the idea, but that is not. That doesn't look like a grammatically correct something. Anyways, although VS Code provides the deactivate function, it serves only as a graceful shutdown callback during the host process termination, and thus does not enable live removal. Moreover, the host separates effect disposal from effect creation in Activate. Yeah. Okay, I get the idea. Violating the locality of console and making complete cleanup difficult to verify. Okay. Party lead activity extensions ما هي pure ما تخلي side effects. هذا السايد افكت الستيت بالتالي تعطي ديزاكتيفي اكستنشن يفهم مثل ستارتي بوست كامل من فيس كود ستارتي كامل ياك يرجع للمود طبيعي. سينو هو ما يعرف ذا اللي اكتيفيت اللي عاد ما قد يتراكيه اكزاكتومون. ما يقدر ما كل شيء قد تو اكتيفيت في الريفرتر ياك ديزاكتيفيت تعطيه منفسه يعني ما هي مطلوبه فهمتني ذو بيجي على فهمتها violating locality of console يعني console مالت اللوكال اللي activate at activate deactivate كلهم console مو واحد تو يو تيري ديل بيري اخرت بيك كويس رداكتي مساجك والله ذاك اسمه ماي ثينج اللي قال له او حمد زين كتب شي هلو حمد زين اي wait a minute انا قلت يعود يوتيوب متروش معي هون شوي محيش من الامور او ما هون رجاج وصل لي بارامتر يا دي بيرسون bonsoir tout le monde أنا اللي يخرص كان يوتيوب متروش يمحي مساجات لا تنظريتي auto mode في auto moderation this is not education is this education I don't know moderation don't moderate my stuff we are based okay cool اوكي ذا بخبار temporal limitation انك مع الوقت ما تقدر تضيف كومبوننت وانت ران تايم ما تقدر تضيف كومبوننت تقلع كومبوننت ما يعني كومسا هيك مشكله بلجن سيستمز العادي special limitation VS Code does not provide extension dependencies for declaring dependencies between extensions but it sees little use sorry VS Code does provide extension dependencies for declaring dependencies between extensions but it sees little use among the top 100 extensions by install count only 7 declare extension dependencies on non-built-in extensions. This scarcity reflects the shape of the extension API, which exposes fixed surface-level extension points, such as commands, views, and language features. Extensions contribute to the host through these points rather than depending on one another. Extensions contribute to the host through these points rather than depending on one another. The API, the extension API. So inter-extension dependencies rarely arise. Moreover, VS Code's mechanism for inter-extension interaction provides no structural contract. It exposes an extension functionality to others through vscode.extensions.getExtension.exports. But the returned value isn't typed any by default. So the dependent cannot rely on a checked interface. For sure, really. It's untyped and do any type, and deal with empty interface or any no type. In short, VS Code steers extensions towards a fixed set of host-provided extension points. And offers no safe, structured way for them to depend on one another. اوكي كول انا فقدني بالمناسبة اذا عدتوا بابديت لاني شير كوميت فكوني شير كوميت قطع الديتاي داكور يا هون يصير ليميتيشن عن هو ما يعطي ما في طريقة بالاكستنشنز يعني واحدة من الدبان اللي تثبتنا على الأخرى. اوكي something like that. That's what I guess that's what they are trying to say. These two limitations are not unique to VS Code. They occur across plugin systems generally. Number two, we have on plugins and extensible architectures. Macy paper. And 7, we have component software beyond object-oriented programming. 2 like old as hell, man. Differing only in degree. Okay. Self-evolving agent harnesses. Modern AI agents rely on runtime agent harnesses. These systems may compose diverse tools, suites, and execution environments govern permissions and sandboxing, maintain session states and persistence, provide context management, and memory systems, orchestrate sub-agents and multi-agent workflows, and expose interfaces to users and automation. A feature harness may generate and deploy modifications to its own components while continuously serving requests. Yeah, beautiful. Model synthesized reusable tools provide a narrower precursor to component level self-modification. Model synthesized كذا اللي معدلها الموديل. Reusable tools provide a narrower precursor to component level self-modification. Each such modification is itself an instance of dynamic composition. Okay. Large models as tool makers in proceedings of the 12th International Conference on Learning Presentation Essay. ينكت كل I'm oh, hey, thank you for the reaction. يو تورا اسمه سبا شو ماسي ياك لباس ياك الخير وخير كبيرة. اوكي سوري سيد شوي هذا يشبع هاي بيبر 2 جيب عجلانة شوي. برينستون ديب مايند 99 يردوا عنهم شنو هو. تول ميكر ايوه الاي لا ماشيين يستحربوا. حق الله ذا يكون عنه شمرات وفي شمرطي. شنو هم كونتريبيوشنات الناس؟ The station of the dispatcher. شو؟ Just some engineering. Bon, هذا دايما event cuts. To be fair, دايما event cuts. But you know, whatever. I don't think this is tool for the Chinese entertainment, tool for scalability. Okay, this is early stuff. Okay, I can respect that. What's you're talking about tonight? LLM? Yeah, that paper. Hi, paper DeepSeek. Okay, عندنا خاطر 4 أيام. وتشوف it piqued my interest. تتكلم عن harness، تعدل harness يعود composable حتى يعود agent من نفسه يبلتي harness براسه، يعود عنده access عن extend harness انا مثلا ده انا بسيجي انا انتريس عندي بيلي انا نفسي كنت يعني روقان عاد بالي انا انترستد بتعديل هارنسز ولا شيء و yeah this is something this is sick مثلا مدير يسوي نوتيجاسيون ماثيماتيك it's fucking awesome يعني it's gonna be interesting excuse my dirty language my language anyways uh, Okay, so self-evolving agent harnesses عندنا نصل للمغرب هنا go back هنا come back نصل للمغرب نرجع اوكي يا جماعة there is one here عندنا تمام تبرر I will come back داني نصل للمغرب نرجع اوكي ذكر let's give it 15 minutes مغرب okay yeah it's interesting yeah you see what I mean اي قلت لي شيء اوكي نصل للمغرب باقي نرجع ذكر المهم بيبر طبعا اللي كي درتها فهمتيها let me put it on in the description يا كي جا حد يشوف فاسيل what is the thing paper link says paper yeah paper study I'm just trying to make sense of it and yes that's it okay جماعة الخير I'll be back and I hope this stuff is it's gonna be full okay ست مرات نرجع إن شاء الله It's funny though. and citrus. اي لا نسمعك. استاذي جيت استاذ احمد عمار. when was this؟ ما يقولوا الوقت انت الخطة. oh what's that؟ قال وين تحصل لنا الصوت؟ I don't know. ما يطلع الوقت. anyways I'm back. في فيورس من قبل. مرحبا، كيف الحال؟ سامعني بعد وقتين ما اسمع يلا سعود؟ إلا ما كنت هون؟ نورون ما تسمعني؟ إذا أنا على حق. Okay, good. Hello everyone. We're so back. Oh, إسحاق. Comment ça va? Comment tu vas? C'est un plaisir de vous voir ici. Voilà. ما شاء الله بخير الحمد لله. لباس. صحة. Okay. Self-performing agent harnesses. Modern AI agents rely on runtime agent harnesses. These systems may compose diverse tool suites and execution environments, govern permission, sandboxing, maintain. Hey, what's going on? Hey, يسلم بخير. What's going on YouTube? IPSEC. nice skin IPSEC. بالنسبة للناس اللي جدد هذا عن هاي بيبر ديبسيك لها 4 أيام خلاص. 3 أيام خلاص. 3 أيام عندنا 4 أيام. 4 أيام يوم سيتي خاطر التريس عم تساعد عليهم الهارنس الديبسيك. قضية very interesting عنهم اللي هي تكلمت عنها سابقا كتير شوية غير تو هذا كما هم عدلوا هارنس ما رواية interesting بالنسبة لي أنا بعد interesting حتى ما هو اللاتو في رواية خمسة تشوفه كل يوم اللي عدلهم هنا تصير رواية سبيسيال طبعا common deepseek W deepseek دائما يعدلوا روايات اللي جراند بريكي للناس تقل الفهم صح. Okay, so let's continue. Model synthesized, أنا كنت قبل كان model synthesized reusable tools provide a narrower precursor to component level self-modification. Each such modification is itself an instance of dynamic composition. Because these modifications occur continuously and with limited or no human حين يقول أحمد عني رجعت على شيء. I'm back to stream. Let's tell Ahmed if he's back to stream. Back to stream. Okay, so because these modifications occur continuously and with limited or no human oversight, the dynamic composability becomes indispensable. Without temporal composability, each self-modification forces the full restart that discards all process local accumulated states. At such frequency, the cumulative invalidity becomes substantial, and in-flight tasks are disrupted repeatedly. Even worse, a faculty self-modification can disable the very process needed to recover. A faulty self-modification can disable the very process needed to recover. Yeah. Without spatial composability, each model must itself detect and adapt to changes in the models it presents as they appear. Without spatial composability, each model must itself detect and adapt to changes the models it depends in changes and adapt to changes in the models it depends on as they appear, disappear, or change identity. And can do so by what is harness? I don't know if I spelled it the right way. Yeah, that's it's called the harness. It's spelled this way, and you wrote it correctly. harness لكت كلود كود فهمتني. هو LLM وحده LLM لا فانكشن تقدر عنها تعطيه تكست تأوتبوتي لك next word من ذاك تكست. اوكي to complete machine. فهمت؟ وهارنس عن اللي تقبل ذاك LLM يتوقع انك تعطيه environment يعود ياكسد ذي على tools كالي tools قد يلانشي sub agents من هو نفسه. لكن هو شنو كلمته كلمة ترجمة شنو عربية متمشي مع الكلمة معناها كلمة تفسر معناها شنو. what is it reheat what is it. you got it. okay you got it. قلت لو الكلمة عنك تسخر ايوه تبغى اللي تسخروا عليه رواية. فهمتني؟ فهمت لي تعدلوا هو مادة خام. فهمت؟ تعطيه ذا هاردنس هيك وتكبر يعني تزاد capability. most capable. so that's it. وديبسيك عدل واحد عندك لود كود عندك كودكس عندك هاي كم من هاردنسات للإلمس مش شات جي بي تي قاعد عادي انترفاس ويب بصفته هذه هاردنس. فكلهم capability تخطى capability. وهم اللي يعدلوا هم ديبسيك عنهم معدلين هاردنس يعود إلم نفسه ايجنت نفسه يعود قد يبلدي راسي يبلدي هارنس وهو نفسه. فاهم يعود كومبوزبل قد بلاج ان بلاي بلاجنات وقد يقلعهم ويديرهم من دون عنه يخلق لهم مشاكل بشكل يعني ستيبل يتم لا ستيبل في التابليت راسه. الرواية فريمان ترسني بيه مستقبلا يعود لا باش واحد الا مدن عدمتين باش عاد قد هو يكري تولات لباس بيهم وياجوتيهم الراس. فاهم ذاك ذوك روايات انترستين. So, hello Discord. Who's that? Yo, Wafa. Good to see you. Is my voice on, by the way? I might. Oh shit, my voice wasn't on. Hello, Wafa. What's up? Good to see you. My voice wasn't on all along. Huh? Hey, hey. How are you? I hope you're well.
I'm doing good. How about you?
Alhamdulillah, لباس.
الحمد لله.
Thanks. So this is about the DeepSeek paper. This is another a continuation of the series of paper deep dive. Okay, so yeah, paper deep dive. This is episode 3 actually. You remember that the last one was about transformer with the lattices and the Sudoku. This is the.
I remember that one.
Yeah, you were there. This one is about this paper, which is very recent, like 3 days ago, 4 days ago, from DeepSeek. It's about building harnesses. That really did pique my interest because, yeah, I'm interested in trying to harness these LLMs, these weird creatures. Okay, so I'll continue. I'm in this section. I'm still at the very beginning though. They will get into some I'm guessing programming language theory. There is a lot of abstractions here and there. There are diagrams. You know, that's kind of stuff I'm a very big fan of. And yeah, a lot of exciting, potentially exciting stuff coming. Okay.
By the way, did you just get started or?
Almost. I'm still at the very beginning. They are still just yapping here. There is no formalities. There is no serious stuff so far. There is no complicated stuff so far. This is just talking. Introduction, the introduction part. So I'm almost just starting. Okay. So I'll continue reading. Yeah, because these modifications can occur continuously. I guess I've read that already. Yep, where was I? Yeah, without spatial composability, each model must itself detect and adapt to changes in the models it depends on as they appear, disappear, or change identity. And do so, and can do so only by an ad hoc means. By ad hoc means, even worse, naive code replacement strategy may silently break dependence, or introduce circular dependencies that surface only after a little time. Okay, the course. So this part essentially was about discussing the case study of VS Code, the VS Code extension system. That they have a lack of temporal and spatial limitation. Temporal here means, to just recap, temporal here, what they are trying to do generally is building a harness that is as much extensible as possible. That you can, everything in it is a plugin. You can plug everything. The agent itself can create plugins for itself. Can extend its own harness. It's not like something rigid, like for example, Cloud Code. Cloud Code, what you can do is just is mostly just skills, just installing skills, I guess. And yeah, and hooks are just basically stuff happens at some events. But it's not. They are pushing this extensibility as far as they can by the approach that they mentioned here, that they did decouple the concept of composability to two things: temporal and spatial. Temporal meaning that a new component a new extension, or when it gets removed or insert or added to the harness, it shouldn't have side effects. For example, in VS Code, you cannot disable an extension, not any extension that you can't. Let me articulate this properly. You can't just disable an extension without reloading the VS Code itself. Not every extension has this limitation, but most of the extensions, they did argue that here. They did mention that here. And for special here meaning the inter-extension communication, extension relationships. That some extensions that you cannot build extensions from other extensions. That as far as I understand it. So VS Code has these two limitations, and what they are trying to do here is to build a programming paradigm, a way of doing programming to have these two kinds of properties available. Okay, and that will allow you to have any kind extensions in a very stable way. So that's roughly a summary of what they have talked about until now. Okay, so now the course gained workaround. One reason dynamic composability has received limited formal attention is that operating systems and container orchestrators already have coarse-grained substitutes. Operating systems yield temporal composability as the granularity of a process. At the granularity, operating systems yield temporal composability at the granularity of a process. Container orchestrators yield spatial composability at the granularity of a service. Okay, I'm really training my tongue here, getting my one reason dynamic composability has received limited formal attention is that operating system and container orchestrators already provide a coarse-grained substitute. Already provide a coarse-grained substitute. Okay, I don't know what this coarse-grained. What does this coarse-grained means? But let's continue. Operating systems yield temporal composability at the granularity of a process. Container orchestrators yield spatial composability at the granularity of a service. Okay. Yeah, sure. I guess that makes sense. I guess that makes a bit of sense. Okay, I can maybe. Okay, we can accept that. In practice, most software tolerates the lack of fine-grained composability by deferring to these coarse-grained mechanisms. A misbehaving model is handled by restarting the process, and the service dependency is managed by the container orchestrator. However, this workaround imposes substantial costs. Temporarily, each restart discards all the process local accumulated states, caches, connections, partial computations, and rebuilding it takes seconds to minutes. Maintaining availability in an interim requires redundant replicas, incurring resource overhead to compensate for an inability to recover a single component. Now, what does that mean? Maintaining availability in the interim requires redundant replicas, incurring resource overhead to compensate for the inability to recover a single component. Okay. Spatially, this is temporally. Spatially, container level orchestration cannot express dependencies between components sharing an address space. And introduces network overhead for interactions that could be local function calls. Both mechanisms operate at the boundary of processes and containers. Yet, modern systems increasingly compose at a finer level. This granularity mismatch demands a compositional abstraction that manages effects and dependencies at the same level as the components themselves. Okay, contributions. Two dimensions of dynamic composability concern, respectively, how computation modify and how they depend on their environments. These two directions are what different systems are what effect systems and co-effect systems formalize. Interesting. Effect systems, monads, notions of computation monads. Okay. Adequacy of algebraic effects. Okay. Comonads. What co-effects? Okay. Unified static analysis of context dependencies. Of context dependence. Interesting. Combining effects and co-effects by grading. Okay, effects provide the formal vocabulary for reasoning about environmental modifications, and co-effects for reasoning about environmental requirements. However, existing formulations restrict reasoning to compile time analysis over lexically fixed scopes, and do not extend it to dynamic scenarios where components arrive and depart at the runtime. By lifting effects to a revertible runtime model and co-effects to reactive dependency resolution mechanism, we obtain a unified formal foundation for dynamic composability, one that is language agnostic and applicable to any software architecture requiring dynamic composition. We make the following contributions. Okay, okie dokie. Let's see. By lifting effects to a revertible runtime model and co-effects to reactive dependency resolution mechanism, we obtain a unified formal foundation for dynamic composability, one that is language agnostic, and applicable to any software architecture requiring dynamic composition. We make the following contributions. We formalize reversible effects. Every context transformation carries an explicit inverse that the runtime tracks. Every context transformation carries an explicit inverse that the runtime tracks. And both tracking and recovery preserve composition. I'm getting the feel now that this won't be this will be a costly. This abstraction is gonna come with a price to pay. It will be a bit of a lot of bookkeeping going around and a big machinery to achieve to make this thing stable with time. I think maybe it will. Well, that's another thing. There is something called effects. The TS, I guess. Yeah, I think it's this thing. Yeah, prediction ready systems. Yeah, okay. This is for making sure stuff doesn't. Look at this fellow. That's a big beard. um, yeah, these guys try to handle errors, you know, in a stable way inside of TypeScript. It's like building a language on top of a language, which is let me is there a fact for this FAQ? FAQ, yeah, good. Okay, yeah, performance overhead. Nice. Effect prevents real performance killers. Memory leaks. Offhand async ops, resource exhaustion. Yeah, they're showing you what you're trading with. Resource exhaustion, exhaustion. What is this? Exhaustion. I don't know how to spell this, but I'll check that later. Inconsistent error handling. The runtime overhead is minimal, and the stricter approach leads to more efficient code organization and execution. No. Effect covers a broader scope than most libraries in the TypeScript ecosystem, combining async control, dependency management, and error handling and observability in one cohesive runtime. See how it compares to RxJS. Okay, I saw this RxJS thing. Never throw it. Is it possible to adopt effect? Yeah. Yes, you can start small, wrapping existing functions, the effect. Got it. Okay, RxJS, okay. It's the same, effect is the same as RxJS and shares its problems. What? What is this page? They will relies on generators, and generators are slow. Effect will make your code and slower. Yeah, okay. This is the complaints. They defending themselves. They are defending themselves. Let's see what they defend themselves with. This is a tangent, but you know it's related to this. I will check it later. But I'm interested in this. Yeah, this thing would happen for. I'm guessing the same thing will happen here with with what they are trying to do. They are just building some kind of an effect thing, but with co-effects also, not just effects, co-effects as well. Co-effects here mean, of course, let me remind myself, the dependencies part, and effects meaning the temporal thing, the what is it? They mentioned they said it in a way that is a lot clearer than yeah, reversible runtime. Yeah. Okay. Every context. I got a bit tired of speaking for a moment. Let me take a minute. 1 minute break from yapping. 1 minute yapping. Break. No. Yeah, break. Oh, 2 viewers. Hi. Don't you have stuff to do tonight watching me talk? Let's chat. Chat, say something. تكلموا يا أهل شات، يا أهل مشاهدين. يا اعتماد تفهم الإنجليزية وأنا أي لا بريك قصيرة، دقيقة واحدة. أنا غلط. Oh, I got 6 viewers, 5. Cool. We're having business is booming today. Shit. Back to stream. So. I guess the minute is over. Okay. Yeah. The contributions. We make the following contributions. We formalize the reversible effects, section 3.1. Every context transformation carries an explicit inverse that the runtime tracks. And both tracking and recovery preserve composition. So the context is recovered upon component removal. This establishes local temporal composability. اوكي لوكال زي ما عندك عرفتي هم نقول كلام عبارات جميلة جدا. We formalize reactive effects. A component declares its co-effect. A component declares the co-effects it requires as a specification. Each change of the context notifies the component against that specification as activating, deactivating, or neutral. This establishes local spatial composability. Okay. The notifications اللي يسندوا ما فهمت شنو اخبارهم يا خير. I didn't understand yet what this notification stuff is, but okay. We unify the effect context and the co-effect context into a single context type. Okay. In which an observational equivalence on the co-effect supplies the effect with independence, constituting a programming paradigm for spatiotemporal composability. Okay. We give a calculus of dynamic composition. Hi, keep going, even 0 viewers. أخير شغال. Yeah, حمد حبيب, merci. Thanks, man. Yeah, I'm keeping going, man. وقع الحقيقة en fait هو دايروا لي هكذا أنا من نفسي دايرة فهمتني donc if there is someone يقرأ معي it's cool. But anyways, at the end, we are winning anyway. Yes. That's something. That's what it's about. Okay, so we give a calculus of dynamic composition, section 4, which combines two mechanisms into the notion of a component and equips its life cycle with an operational semantics. Which combines the two mechanisms into the notion of a component and equips its life cycle with an operational semantics. We implement this. Okay. We should. Which combines the two mechanisms into the notion of a component and equips its life cycle with an operational semantics. Its meta theory carries spatiotemporal composability from a single component to the whole system of interleaved components. We implement these ideas in Cordis, a meta framework for spatiotemporal composability that provides a core library of realizing the formal model with effect tracking and co-effect resolution, as well as a declarative component loader with a configuration conciliation in hot model or placement. Okay, cool. Preliminaries. This section provides a concise overview of effect and co-effect systems. The two theoretical pillars underlying our work. We assume the familiarity with basic type. Man, I should go. I watch later inshallah. Thanks for sharing. Yeah, okay. Good to see you, man. Good to see you. الله يرفعك. مرحبا. Thanks for coming. We assume familiarity with basic types, type theory and category theory. Okay, sure. The goal here is to fix notation and introduce key abstractions that section 3 is to fix notation and introduce key abstractions that section 3 will operationalize as runtime mechanisms. Okay. In the simply typed lambda calculus, STLC. Okay. What difference is there? Formulation of the simple type, the simple theory of types. Okay. 1914. Church. They are sending out to church directly. 21. Types and programming languages. 20. Okay. Let me do. It's a book. It's a reference book. Good. Okay. At typing judgment, gamma T, say that the term T has type T under the context gamma. Okay, an effect system refines the type to describe what side effects a computation may produce, yielding judgment of the form. Okay, so they are just tagging it with effect or something. I don't know. Let's see. Here, the result type is annotated with annotated with an element of an effects algebra that describes which side effects the computation may produce, enabling compositional reasoning about stateful computations. This originates from Lucassen and Gifford. Polymorphic effect systems. There is one. 88. Who introduced a kinded type system distinguishing types, effects, and regions to discover scheduling constraints in parallel programs. Monadic effects. Mugi first in his paper Notions of Computation in Monads first modeled computational effects categorically via monads. Wilder, I know his paper. I even have the paper of the guy, which should be like here, docs, monad. Yeah, I have both of them, Mugi and the guy. Monad. And this is Mugi's paper. And this is one of the paper. This is back when I was trying to learn about Haskell and monads. Okay, so monadic effects. Mugi 16 first modeled a computational effect categorically via monads what the popularized approach in Haskell. A monad T, this is the What is it? This is the units, and this is, I think it is the t is a functor, right? And these two things are natural transformations. This one is a natural transformation, and this one is a yeah. Yeah, it's one of them is a unit and the other is a roton. I think this is the unit and this is a roton. Yeah, that's what I think. Do I have GSCI? Haskell? No. And a category C encapsulates an effectful computation as a value of type TA. Okay. With eta associating A to TA, lifting pure values, and that one, the unit one is collapsing, is flattening, meaning this flattens. What is it? Mu takes T of TA to TA. A here being an object of this category. Sequencing in nested computations, and T is an endomorphism. Is an underfunctor. Sorry, T is an underfunctor of this category. Yeah. Sequencing nested computations. Lifting pure values in eta sequencing nested computations. Yeah. Okay. Classic instances include the maybe monad for partiality, and a state monad for mutable states. Maybe monad is just you have a value or have or you don't have it. So this T will box the value, and a box of the box will you flattening it by this eta, and this is the unit that you take any object and you take you get a maybe of it. Yeah. Okay. And state monad is for immutable state, an IO monad for external interactions. Okay. Algebraic effects. Adequacy of algebraic effects. 24 notions of computation determine monads. Plotkin and Power show that algebraic operations determine monads, especially establishing a framework in which effect interfaces are decoupled from their implementations. Sorry. One moment, I'm checking my chat. What you know. Sorry, chat. One moment. Yo. Okay. Hey viewer, lovely viewer. Sorry, I see the garage part. Have a lovely reading. Sure. Okay, cool. Algebraic show that show that algebraic operations determine monads. Show that algebraic operations. Okay, algebraic operations determine monads. Establishing a framework in which effect interfaces are decoupled, from their implementations. An effect signature sigma declares a set of operations, e.g., get, put. Okay, this seems like some kind of adjunction, maybe. I don't know. I don't know what I'm saying. For state programs invoke. Okay. I don't know. Programs invoke operations freely without committing to a partial interpretation. Programs invoke operations freely without committing to a particular interpretation. I don't know what that means. Plotkin and Pretnor subsequently introduced effect handlers, which interpret operations by providing continuation semantics. Handle E with op v kappa associated to 3 dots ellipsis. The handler receives the operation argument v and the delimited continuation k kappa, which it may invoke 0, 1, or multiple times, enabling exceptions, coroutines, and non-determinism, which within a uniform framework. What that means? To use algebraic effects and handlers invited tutorial people. Okay, languages such as Coca, F, and OCaml 5 have adopted algebraic effects in varying design trade-offs. Co-effects now. That was about effects, co-effects now. Duality to effects, co-effect systems enriches the context rather than the type, yielding judgment of the form. Okay, co-effect here. Here, the context is annotated with an element of a co-effect algebra describing what the computation requires from its environment, such as resources to access, permissions to hold, or services to depend on. While effects model a program's impact on the world, co-effect model the world's constraints on the program. Comonadic co-effects. I love it. We are getting. This is a meme, yeah, صح. This is a good meme. This is a beautiful meme. Let me share this in the group. This is a good meme. This is a good meme. Let me share the link.
Theory. 27 unhelpful facts about category theory. Fact 1. This video is a joke. Please don't take any of it seriously. I am in fact studying category theory properly and I do enjoy it, but this video idea came to me and couldn't be stopped. So please enjoy this context-free exploration of category theory's weirdest works, most of which are actually true. I may make a serious video on this topic at some point, but for now I apologise for the trying to what's generally a useful mathematical subject. Anyway. Fact 2. A category consists of a collection of objects. For any two objects, a Hom set of morphisms from one to the other, and a composition operation, such that composition is associative and has identities for each object. Easy, right? Fact 3. Not easy. Hom sets? Morphisms? The hell is an ob? You don't need any of those to understand category theory. No, you need that meme with two pictures that Pram from the office says are the same picture. That's all mathematics is, right? You take two things and find a theory that abstracts away their particulars to deal with them together. You know, that whole thing about coffee mugs and donuts and transport is can't tell the difference between them.
Okay, so let's continue. I got distracted a bit by this joke. Okay, so yeah, command icon effects. Let's decrease this bit. How is the lighting going? Yeah, not bad. Oops. Take a bit. The idea of using common ads to structure context-dependent computation was first developed by Ustalu and Veen, common-adic notions of computation. Okay. Who proposes symmetric, semi-monoidal common ads as the dual of Mogi's monadic framework for effects, capturing notions such as data flow and attribute evaluation. Petrick et al. Built on this foundation to propose co-effects as a unified static analysis of context dependence. A comonad d epsilon delta captures context-dependent computations. Epsilon taking dA to A, okay, extraction. Okay. Extracts the current, which is exactly the inverse of our boy here, the unit. Okay. They extract the current value from the context, and okay, from the context, and delta takes dA to dDA, deduplicates context for nested access. It duplicates context for nested access. The environment comonad dx, which is equals to E cross X, models dependence of on a fixed environment E. A fixed environment E. The stream comonad dx from n to x models dependence on temporal data. Okay, these are two comonads, example comonads. The one defined by this associating the environment with directly with the objects, okay, which models the Cartesian product, models the dependence on a fixed environment E. Okay, the stream comonad, which is morphisms, the set of the home set between how come it's what the hell is that? What is the stream comonad? That's weird. What's the stream comonad? Models dependence on temporal data. Okay. Get the hell out of here. I don't want you to take a look at my files. Just show me my shit. Graded co-effects. For fine-grained tracking, graded co-effect systems use pre-ordered semi-ring S, which is S less than or equal to plus times 0, 1, etc. Okay, get co-effect systems use pre-ordered simmering. Okay, that's a ring. What is the simmering? I don't know what the simmering is, but you can be okay with a ring. Can go with that. Tracking grid co-effect systems use a pre-ordered simmering as the maybe it's a ring in the order thing, in ordering context. Maybe that's something. As a yeah, I think so. As as the coeffect algebra. A discipline data unified with graded effects by Gabaradi et al. Okay, this is 33, which is a core quantitative coeffect calculus, and this is 19. Which is combining effects and coeffects via grading. Elements of S annotate each variable binding to quantify its usage. 0 for unused, 1 for linear use, n for bounded use, and infinity for unrestricted use. The simmering operations compose coeffects sequentially, times and in parallel, plus enabling precise resource tracking, sensitivity analysis, and information flow control. Distance makes the types grow stronger, a calculus of financial privacy. Okay, 35, which is a core calculus of dependency. 36, which is a lattice model of secure information flow within a unified algebraic framework. 37, which is a relational theory of effects and coeffects. Okay. Relationship to dynamic composability. Effects and coeffect systems organize reasoning about computation along two complementary directions. Effects describe how computation modifies the environment, whereas coeffects describe how it depends on its environment. These two directions, beautiful. These two directions correspond to the two dimension of dynamic composability identified in section 1. Temporal composability and spatial composability demands that the component modifies the environment. The component's modifications to the shared environment be reversible upon unloading. And the relevant effects are the stateful ones, which durably transform that environment, and doing such transformation requires it to admit an inverse. Spatial composability demands that the intercomponent dependencies be declared and managed interactively. Such dependencies are the very thing coeffects capture, and managing them amounts to resolving each against what the component supplies. However, classical effects and coeffect systems are static instruments. Effects are tracked within lexically fixed scopes and discharged by compare-time handlers. Coeffect annotations are verified against context determined before execution. Dynamic composition by construct requires these guarantees to hold for components that arrive and depart at some time, against context that evolved continuously. No fixed lexical scope can delimit a plugin loaded after the deployment. No fixed lexical scope can delimit a plugin loaded after deployment. What does that mean? A fixed lexical scope can delimit a plugin loaded after deployment. I don't know what that means. Okay, let's just zoom a bit and wait. Yeah. 3.1 reflective effects, reactive coeffect. And then what we do, unify in 3.3. Okay. section 4 هي اللي فيها calculus و dynamic. اوكي. Yeah, they're just starting. This is 88 page, man. This is crazy. This is crazy. This is Confluence at some point, and this is the core library. And after that, we get the implementations, big tracking, modify. Interesting. Interesting stuff. Okay, cool. Let's take a break. 1 minute break. From hip break. It's called reading break. Okay, hip break is fine. Yeah, we are at this relationship dynamic composability. Yeah. Oh, viewers, love ya. There is 5 here. Yeah, cool. Hey viewer, what's up? We are in a small break, okay? Small break عن كلام. Small break from talking, from reading. You can, by the way, join the Discord. I invite you to do so. Yeah. Your partner, collaborating. Okay. That's kind. Please don't tell me I'm the. I'm coming back. I will just take a. I will just. Be right back. Right back. Right. Let's be honest. 2 minutes. You'll be right back. In time, almost in time, but I'm back. I'll be back.
Computers now have primary control of critical vehicle functions.
Everyone, but no one is still here to talk about. Anyways. Yeah. Bye. Oh, yeah, it doesn't fucking matter, man. It doesn't fucking matter. Let's continue. Let's put some music though. Hey. Hi viewer. No viewer. No viewer. How's the lighting now? That's super good. Not super good. Okay, so let's see. Okay. Async command is a command structure on an infinite stream, infinite list. It's a classic example of a command after reader writer. Ah. Wait a minute. Data stream A. Okay, infinite list. Is it though? Yeah, infinite list. Okay. A stream is a value plus the rest. Yeah, an element of A together with the context. The suffix, the suffix. The value plus context shape is exactly what command gives you. Three command methods: extract, which take string, extract, hit the current value. Okay. Extract. Yeah. Okay, because you just the head. Okay, stream A, duplicate, stream, and axis, duplicate, S, also suffixes. And extend. There is an extend. What the what? Ah, okay, so this is the. This is taking objects, and this takes fun morphisms. Okay. Okay. With map of duplicate. Okay, so it's just a construction over extract the current element. Duplicate turns the stream into stream of streams. S, tail S, tail S. Ah. This is the one step further into context operations. Command analog option. Give me the dual core dual monad for string. Okay, so that's about that part. Oh, hey, we have a viewer there. Thank you for that like. I saw it. I see it. I can also put the thing here, so you can freely chat. Okay. But my face is over text. Anyways, okay, good question. What is good question. The story is symmetric. It's asymmetric, a bit subtle. Short answer: writer is always a command. Reader is a command exactly when its environment is a monoid. Which is precisely how you get streams command. Okay, so it's a stream, so you take writer. Yeah, you have the extract, which which you read from the stream, right? That's the reader. The reader, you read from the stream. Writer, what you do to the stream. I don't know what to do to the stream when it. What is the extract for the writer? Right, AW, a monad if and only if is a monoid. If and only W is a monoid. Okay, it adds two parameters or to annotate tags or something. I don't know, annotate parameters. Let's say you say. If and only if W is a monoid, appends to the output. Okay, yeah, sure. Common for any W, no structure needed. This is the env. Okay, env is the. Okay, env is writer. Extract AW gives you A. Duplicate AW gives you AW for sure. Yeah, sure. The environment. Yeah, this is weird because okay. F AW gives you F A W. Sure. The environment W is just carried along, immutable. You can check the loss trivially. Duplicates repairs the same W. The extraction discards it. This is a degenerate command, a value with a fixed environment attached. Okay. So this is what the E cross A that E cross X that I've seen before, but now it's X cross A, X cross E, yeah, because W is the environment here. But why they call it writer? So I still don't get it. It writes to what? What does it write to? Command for any R is the classic reader. Monad for any R, classic reader. Command if and only if R is a monoid. Extract F MMT. Okay. Takes a map and evaluates it on evaluates it on MMT, which is, what the hell is that? I don't know. F of R1 R2 J is defined as, yeah, okay, duplicate of F and R1 and R2. Take F R1, this thing, R2. This is the monoid, guessing, yeah, this is the monoid operation. You need MMT to extract a distinguished current position. Okay. And this operation, this diamond to duplicate. Combine two context offsets. You combine two context effects offsets. By the way, why? The laws go through exactly the on the monoid laws, associativity, identity. What? Okay, the law, yeah, okay. They mean that this is a monad because R is a monoid, yeah, comonad, sorry. The string comonad is this instance with R equals to n. Addition MMT is 0. Ah, MMT here is the what is it? Yeah, okay, sure. Sure, this is the natural element of the monoid. Sure. This we have, and here we have a monoid, the monoid n, natural integers string. Monoid is instance. Okay, streams are duplicates. Okay. Shift the window by each step. That's the connection in the previous message. Deep duality, state store. Where it really is state, which is both at once a monad and a comonad. Takes an SA and hands you back S, a map from S to AS. This is the state. No. State is a monad that takes two parameters. Shit. Sorry. Store takes two parameters, SA. Maybe I will take this here. Yeah, that's better. That's probably better. Yeah. We got some viewers. Sometimes we get viewers. Yeah. سر مستحفي at خلعتني. Damn. Okay, so I didn't fix my hair. Oh, anyways, that doesn't matter. Whatever. Okay, state takes SNA and gives back AS. A morphism from S to AS. And store takes an SNA. Okay. State is this it's defined by this under functor, and AS and store is this under functor. Takes an S. No. This is not an under functor. Okay, this is an under functor because that's it's a morphism. This is a morphism. Okay. Is that true? I don't even know. Common Koreas. Okay. It's isomorphic to this thing. Okay. Same type, two structures. As a monad, use thread states through computations. As a comonad, extract fs, duplicate fs being fs, applying fs, and duplicate fs is this lambda sprang. Yeah, okay. You probe. Well, okay. Okay. You prop. Yeah, okay. You prop a function at the focused position. The extender evaluates every position a length like focus plus context. The general pattern, a command is a value with context you can look outward from. A command is a value with context you can look outward from. A monad is a value you can feed context into. Okay. The tuple AW gets the trivial monad because the context is just sitting there. Function RA only gets one environment. Only gets one environment, knows how to combine its offsets. Okay, alright. Okay. The deal of the stream is the right of the stream monad is the right monad on the additive neutrals. A value paired with a counter. Okay. Stream as a monad. Stream A. Which is map from the integers to A. Morphism from integers to A. Read context. Dual as a monad. Writer in A. AN. Write context. Haskell. Data counted. Counted A. E. Nat. Instance functor counted where fmap is fa and instead monad counted where return a is a0 okay am which is f, just call it b, this thing n equals to f of a in bn. Okay, this is this is definition of the thing. What the fuck? How we are defining something without even oh, this is so fucked up. Yo, wait a second. What is that? Okay, it isn't a built-in for escapade, it's just defined. It means that depends on which library defines it. If you I need somebody. I'm gonna fix data constructor at the liberty. Okay. This of A is a constructor. Common cons snock cons in revert for length indexed vectors. Most common use. vec n nat and type, I think type nat a of a where nil is a vect length 0. Type a. What's that a? I don't know. And that thing, you give it an a, and with vec of n a, you get vec n plus 1 a. Okay, cons snug for length. Okay. Okay, x prevents x and bumps the length by 1. Okay, pipes.core pairs the producer with the consumer into a pipe. Producer AMR, consumer AMR, pipe AMR. What the fuck? Custom type level operators with type operations, data kinds. Please don't let me have an imposter syndrome. Please. In a type can a thing in a type can refer to a promoted data constructor or a separately declared type operator. Family. Okay, got it. What the fuck? These guys are insane. Allah. Damn. Duplicate FM1 into okay. That's crazy. I think that's composing monads, right? Yeah, I think so. Takes an element of the monadic value. It takes a monadic value. It takes what's a monad? let's see what's a monad. A monad is type class that packages context and effect values around values plus 2 operations. Monad M, where this bind. Okay, it's called bind. Bind takes MA and A of MB. Okay, of that type and values of that type, and computes computes for you an MB, right? Yeah, okay. Beautiful. Fine. Okay, wrap plain value. Beautiful. That makes sense. You can't get out of A. You can't get the A out of MA directly. That's often impossible or unsafe. But with binders, you use the A inside of a function that produces another MB. Context flows along automatically. Boxes. Analogy boxes. Maybe it's a box. Okay, a list is a maybe an empty list. That's why you cannot. So for a list, what we get for a list? We get the list. We get something that maps an element into a list. We can apply these to the elements in the container. Okay, in the boxes. A of A. Before giving an A. Before giving an A. Okay. Either in A box that either has a value or an error. Okay. From a box, do something to the value, get a new box. Write a return and just put value in the box. What makes monad the loss? Any monad instance must satisfy the loss. This identity return x f is exactly just an f. Okay, wait a minute. No. Ah, okay, sure. For sure. Left identity. Right identity. Okay. Associativity, which is things are associative, that the bind operator is associative. Okay. These are just the operations that you will. Okay. Compose you would expect. These are just the operations compose you would expect. I think what happens at the seams. The real points monad are just about side effects per se. They're about composition. Maybe compose computation and I can fill, either compose computation with error messages, is compose operations, multiple results, under determinism. IO compose computation that interact with the word in order. State compose computation that carry multiple data, useful data. Reader writer count. Okay, parser count. Okay, why is a parser monad? Why is parser monad? basic parser, basically parser A string get ether error. Ah, okay, sure. It's just the way to compose a function that consumes return if you satisfy one of those. Ah, okay, sure, for sure. Bravo. Either or the parser count. Please count. On it. Continuation on it. Perhaps continuation written continuation parsing. Okay, continuation. But instead of returning a value, return person takes continuation, passes the rest of continuation and passes the results to it. Ah, okay. I should do the fuck. I should do Advent of Coding as call for sure. This is epic. This is really epic. This is really epic. This is epic. Okay. It's the get line. Get line is yeah. And then if you do that, maybe to that function, fix another get line. Okay, and put that as a into y. It's okay. Then append. Yeah, cool. Then return. Yeah, cool. 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 That's fun. Take constructor m it binds hey man. Okay. What's about? It's a monoid in the category and the functors. Okay. The constructor m binds attack constructor m with bind and return that follows the law. Beautiful. Şimdi şuradan koyacağız. Booze. Yo, my man. I'm staring.
That's not licensing.
Hey, sorry for being too late. Let me take some more water. Sorry. Okay, beautiful, 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 beautiful. Yeah, sure. You just define the the effect here and where to put that. Use data. Yeah, okay, the notation is fun actually. Yeah, okay, cool. Okay, cool. Another step constructor M, you define the notation, follows and does. Bind is the sequencing position operator. With combine. Monads lets you program with effects while staying pure. The effect is described by the values type and Haskell's runtime executes it only for the UI. The effect is described by the values type. The Haskell runtime executes it only for IO. Okay, if you want, I can walk through how maybe. Okay, it's fine. Yes. Let me this. Okay. But famously opaque. It's usually said to be as a joke. It's unpacked by piece, the ingredients category. I'll point out. So instead of a monoid of values, it's a monoid whose elements are unfactored. What are the monoid operation here? In category theory, in the category for an unfactor M, the identity element is the identity functor. The return of pure of the monad, search pure of the monad, third monad.
control computers now have primary control of critical vehicle functions.
Okay, this is add. Right, and it's just an X. F, we define, okay, just of X being bigger function. It's a function. Nothing. Use not like nothing. Yeah. Okay. Unwraps and applies X. Yo, hello Hamado. How are you? شو ماسك لباس؟ بخير. لك ما في. Define operation. Unwraps. Applies F. Or short circuits with none if there is nothing to unwrap. Shop is flattened. It's just mix. It's just X. Let's see it too, man. Let's see it. Let's see you, my man. Ah, okay, that's cool. That's cool. I see the point there. I see what you mean. I see. What about, yeah, what about just of just